Okay, let us see another example in toppling. So that one video shows a uniform solid made up of a cylinder of mass 6 kilograms and a cone of 4 kilograms. As you see there, find the center of gravity of the solid. If the solid was put on a rough solid, on a table rough enough to prevent it from slipping, find the angle through which the table was tilted when the solid was at the point of toppling. So first of all, we first get the center of mass. Now, what we do now, they are giving us mass. Means that we can able get the weight of the two. But now our idea is to get the cylinder center of gravity, which I'm going to call G1. Okay, I'm going to call it G1 there. And then I'm going to call the center of gravity of this one G2. But now I'm going to determine them using this as my axis. So I'm going to call this as my y-axis, and I'm going to call this as my x-axis. So that's how I'm going to determine them. Or you can use the line of symmetry to determine them. That is also okay. Okay, if you use the line of symmetry, then the idea is also okay. Now, first of all, the weight of the cylinder, of course, we know that if we have it horizontal, now the cylinder, its weight now is going to be h over 2r. The vertical distance from here to here. Remember, this is where we have this as 14 centimeters, and we have this radius as 7 centimeters. So meaning, if I want the center of gravity, remember, for a cylinder, we said this center of gravity for a cylinder is always at h over 2r if it's horizontal. If it's vertical, then you just interchange. It becomes r comma h over 2. So whenever it's horizontal, so we have from here, the height is horizontal. Okay, so now when we get our height by this will be 7. And then our radius is also 7 from here up here. So that will be the center of, and here that's where our weight is going to act. Remember, this one was having, the center was having 6. So its weight is going to be 6 G because its mass was 6. We get the mass times G. When I come to this, its mass was 4. So we have 4 G. So here now we don't need to get the idea of multiplying, getting the volume, because here we are giving the weights, the masses of these ones. If we are not given anything, then you would have to use the idea of getting the volumes and then relate to using the weight per unit area. Per unit volume. Then here, you see that now we are getting it from here up to here. So from here up to here, we are going to get the x coordinate. And then from here up to here, we get the y coordinate of this center of gravity of a cone. Remember the center of gravity of the cone, we said if it's like this, then we get from here up to here, it will be r, the horizontal will be r. Then from the base to the center of gravity of the cone is h over 4. If you come from the vertex, it's 3/4 h. Then if it's you treat it like this, then this one's just interchange in that order. So this one comes here, then this one gets there. As simple as that. If you treat, they just change. What was the x becomes the y, and what was the y becomes x if you treat. So if it's vertical, this is the idea. If I tilt it now, this one comes here, this one goes there. As simple as that. So to get down this distance from here up here, they are giving us 7. So it should be a quarter of 7. So meaning the distance from this here. I need first of all to get this distance from there up here. So that distance is going to be a quarter of the height. Remember they gave us from here up to here is 7. So it's going to be 7 over 4, which is going to be 1.25. Yeah, 1.75. So this one is going to be 1.75. Now I need it from the x-axis. So from here up to here, I'll get 1.75. Then I add on 14. So it will be now 15.75, comma. Then from the x-axis, I want now the vertical distance from here up to here. It's going to be the same from here up to here, which is the radius of that, which is 7. So from there now, we need to get our coordinates x bar, y bar. It's going to be, we get the weights times where they are located. So we get weight 1, okay, weight 1, and then its coordinates. So we have them there, and there's something because we have been doing these numbers for a long time. So now the weight I have, the first weight is G, 6G, then it's acting at 7, plus the second weight, which is 4G, is acting at 15.75, then 7. They're all over the sum of these two weights, 6G plus 4G. And so you get a calculator and you press these things, Y bar, is that our G is common. So this will give us now, when we press those things, let me put as I press there. When I press me, I get 105. Of course, our G is common, so we divide it through by this G. Okay, G. Then down, I'm getting 70D. The whole I'm dividing with 10D. And so when we divide there, up there we get, when we get this divided by that, we get 10, 5D divided by 10D. Then I'm getting 70D divided by 10D. And so this one will give me, this would be 10.5, then this would be 7. Therefore, the center of gravity of solid is at 10.5 centimeters, 7 centimeters. So this is the idea. So that's where the center of gravity is. Now, the next idea, now they are pressing this solid. Of course, to press it, we are going to put it upright. So if we put it upright, now this is the case we are going to be having. So this is my horizontal. Then we are putting it, and then we are tilting this at a certain angle, which we want, which is theta. Now, this is going to be my, of course, this is going to be the case, like that. So that's how mine is going to be. Now I'm putting this cylinder here, as you can see. Of course, its center of gravity, you see 10, is going to act somewhere here. That's how where I have my center of gravity. Of course, my weight is going to come down there. Of course, this weight now is going to be the weight of the total. When we add this plus this, which is going to be now 10G. So this is my G, which is at, now, because we have now from horizontal to the vertical, means that these two are going to interchange. Now the center of gravity of this one is going to interchange if you put it upright now. So this one will interchange now. So this one will come now. This one now comes here, it becomes now 7, 10.5 there. So you have to note that. Then, of course, we are going to be having this line of symmetry there, in that order. So remember, now if this is, it means that now, from here up to here, from there up to there, our y is 10.5 centimeters from there up there. And this is from here up here is going to be our radius, which is 7 centimeters, as simple as that. So this angle is going to be the angle there. So the only thing I need to learn here is when you tilt this upright now, the center of gravity is going to change. This one come here and it comes here because the horizontal. So from there, I think we see that we can aggregate using that, using this triangle. Let me pull it out. So this is going to be the triangle. Okay. When I do it like that, people will get lost. They won't. Let me pull it out the way it is there. As you see it there, this is going to be my E. So it's like that. Then this is like that. Then we have this line here, as you can able to see there. So of course this is perpendicular there. So this one will have 10.5 centimeters, this one we have 7 centimeters, and this is our theta. From there you can see that my tan theta is going to be, remember we said this angle is the same as that angle. So this tan theta is going to be equal to the opposites, which is 7 over the adjacent 10.5. Here my theta is going to be, this is our part B. It's going to be 7 divided by 33.69 degrees. So this is the angle where the table is tilted. So now let me make this note for the center of gravity, and then you look at it. I'm going to pray, but let me note. Okay, this is the note I wanted you to take. When it's interchange from horizontal to vertical or vice versa, the coordinates of the center of gravity also interchange, say from to, as simple as that. So that's the idea. I wish you well.